Have you ever stopped to think about what's actually in the air you're breathing right now? I mean, there are countless gases all around us, and a lot of them are totally invisible and have no smell. Figuring out what they are is absolutely crucial, not just for safety in factories, but for our own health and for the planet. The key to seeing this invisible world? Well, it lies in some seriously clever technology. So let's dive in and see how it works.
It all comes down to a remarkable piece of tech, just like this one. This little cylinder is an electrochemical gas sensor, and you can think of it as a silent guardian. It can pinpoint specific gases, maybe something dangerous like carbon monoxide, with incredible precision. But how on earth does this tiny thing turn an invisible gas into a clear, measurable signal?
To answer that, we really need to get our heads around the basic principle. So let's start with a simple definition of what we're even talking about.
At its heart, an electrochemical gas sensor is basically a tiny chemical engine. It's designed so that when a very specific gas molecule shows up, it triggers a chemical reaction. And that reaction? It produces a small but totally measurable electrical current. The more gas there is, the stronger the current gets. It's a really elegant and direct way to measure something you can't even see.
Okay, so now we've got the big picture. Let's get our virtual screwdrivers out, zoom right in, and take a look at the internal components to see what really makes this device tick.
And here it is, the blueprint of our sensor. Now I know at first glance it looks a little complex, but this diagram shows every single critical part, from the outside layers that protect it all the way to the chemical core. Let's just walk through it piece by piece. First up, let's talk about the gatekeepers. Before a gas molecule can even get to the important stuff, it has to pass a whole series of protective layers. You've got membranes to keep moisture out, a filter to block dust, and a tiny little capillary that controls exactly how much gas can get in at once. And of course, an O-ring to seal it all up tight. All these parts work together to make sure only the gas we're looking for can reach the sensitive core. And now we get to the heart of the matter. Inside, you find 3 electrodes sitting in a special chemical bath called an electrolyte. The most important one is right there in the middle, the sensing electrode, or what engineers call the working electrode. This is where the magic happens. It's the stage for the chemical reaction. The other 2, the counter and reference electrodes, are there to complete the electrical circuit and just keep the whole system stable and working properly. And finally, you have the wires and pins that carry that all-important electrical signal out of the sensor.
All right, we've seen the parts. We've identified the core components. Now, let's put it all in motion and see exactly how this tiny chemical engine actually generates a signal.
This simple diagram really boils it all down. You can see the gas molecules coming in from the left and hitting that sensing electrode. The moment they make contact, bam, it kicks off a chemical reaction which frees up electrons. Those electrons then start to flow through the circuit over to the counter electrode, and that flow of electrons, well, that is a measurable electrical current. It's a direct one-to-one conversion of chemistry into electricity. Let's break that down into 3 really simple steps. Step 1, gas enters. The target gas drifts into the sensor through all those protective layers. Step 2, gas reacts. It hits that special working electrode and a very specific chemical reaction happens. And step 3, signal out. That reaction generates an electrical current. You could think of it like a tiny specialized battery that only turns on when its specific key, the target gas, is put in the lock. The more gas, the more keys, the stronger the signal.
So we have this unbelievably clever device that can see specific gases. But this isn't just some neat tech curiosity. Let's talk about why this technology has such a massive impact in the real world.
The reason these sensors are pretty much everywhere comes down to a few amazing features. For one, they are incredibly accurate. They're also highly selective, which means a carbon monoxide sensor won't be accidentally triggered by, say, oxygen. Plus, they barely sip any power and work perfectly fine at normal room temperature. This combo makes them cheap, reliable, and super easy to build into all sorts of devices.
And that, of course, leads to their critical life-saving applications. We're talking about the carbon monoxide detector in your home that keeps your family safe while you sleep. We're talking about environmental monitors that check our air quality and sophisticated medical systems that make sure patients are getting exactly the right amount of oxygen. In countless factories and industrial sites, these sensors are the first line of defense against dangerous gas leaks. They are, quite literally, lifesavers. So we've just peeked behind the curtain at this elegant bit of technology that allows us to perceive a world that's totally invisible to our own senses. It really makes you wonder, if we can build a device to see invisible gases, what else is out there, all around us, just waiting for the right clever sensor to reveal it.